1267 hertz. You can see a short tube gives you a very high frequency. Another one. 3 successive resonance frequencies in an organ pipe are 1310, 1834 and 2358 hertz. Is the pipe closed at one end or open? In other words, is the pipe a closed pipe or an open pipe? What is the fundamental frequency? What is the length of the pipe? Now, do you understand the given information? You are given that these 3 frequencies are 3 successive frequencies that will resonate with the frequency of air column inside a tube. Now, you are not told that this is the fundamental. We don't know the fundamental. This may be some 3rd harmonic or 4th harmonic and so on. The only thing we know is that if this is one frequency that resonates, the next frequency that resonates is this, and the next one is this. These are 3 successive resonant frequencies. You need to figure out these resonances are coming from an open tube or closed tube. Alright, tell me, first of all, what is the difference between an open tube and a closed tube? The major difference is, in an open tube, all the harmonics are present. Whereas in a closed tube, only the odd harmonics are present. The fundamental, the 3rd harmonic, the 5th harmonic and so on. Whereas an open tube gives you all the harmonics. And that is what we're going to use in solving this problem. If the pipe is open, then the following conditions will be satisfied. What are the conditions? Since the higher harmonics are integer multiples of the fundamental, in an open tube, if the fundamental is known, the 2nd harmonic, the 3rd harmonic, that is 2 times the fundamental, 3 times the fundamental, 4 times the fundamental, are all present. That means, if this is an open tube, the difference between these 2 will be the fundamental. Is that right? Similarly, the difference between these 2 will also be the fundamental. So, if this is an open tube, the difference between consecutive resonance must be equal to the fundamental frequency. The difference between the 5th harmonic and the 4th harmonic is the fundamental. The difference between the 10th harmonic and the 9th harmonic is the fundamental. So if the tube is an open tube, the difference between successive resonances must give you the fundamental. Now here, that difference is, let's find the difference. 1834 minus 1310 is 524. 2358 minus 1834 is also the same thing. Now what is the second condition? The second condition is the ratio of any harmonic to the fundamental must be an integer. Is that right? Well, let me show you that. Well, if F0 is the fundamental, then F1 equal to 2 F0. Now F2, let me call it 2nd harmonic. The 3rd harmonic will be 3 F0. The 4th harmonic will be 4 F0. Now what does this mean? It means the ratio of any higher harmonics to the fundamental must be an integer. 2 F0 divided by F0 equal to 2. 3 F0 divided by F0 equal to 3. 4 F0 divided by F0 equal to 4, and so on. Well, now can we check if this is true in this case? Let's go and have a look at one more time on our fundamental. This is the difference between the successive frequencies. Now that means if this is the fundamental, then if you divide any of these higher harmonics with the fundamental, you must get a whole number, an integer. Then you can conclude that the tube is an open tube. You understand that? If these are the higher harmonics in the open tube, and if this is the fundamental, which is the difference between these two, also the difference between these two. If this is the fundamental and these are the higher harmonics, then you take the ratio of the higher harmonics to the fundamental, then each of these must give you an integer. Now, shall we try? Is that going to be the case? The ratio of any harmonic to the fundamental must be an integer. Here, 1310 divided by 524 is 2.5. It is not an integer. So what is the conclusion? The tube is not an open tube. So therefore this tube is closed at one end. Alright, now you know that the tube is closed at one end, and the difference between the successive resonances is 524 Hertz. In a closed tube, only odd harmonics are present. So therefore, the difference between any two consecutive resonances must be equal to twice the fundamental. Isn't it? In a closed tube, you have, what do you have? You have the fundamental, then you have 3 times the fundamental, then you have 5 times the fundamental, and therefore if you take the difference between any two consecutive resonances, 5F0 minus 3F0 is 2F0. The difference between any two consecutive resonances must be equal to twice the fundamental in a closed tube. Whereas in an open tube, the difference between consecutive resonances equal to the fundamental. You will see the difference there? Alright, so what is the fundamental frequency here? If this is the difference between successive resonances, the fundamental frequency is F0, then 524 is 2F0. Therefore, F0 is 262 Hertz. Look at the argument that we have made in this problem. The given frequencies are therefore the 5th, 7th and the 9th harmonic. The first frequency, 262, is 5 times, 262 times 5 is 1310. 262 times 7 is 1834. 262 times 9 is 2358. So the fundamental frequency is 262. This is the 5th harmonic. This is the 7th harmonic. This is the 9th harmonic, and so on. Alright? For a closed tube, you know the fundamental now is 262 Hertz. And what is the fundamental frequency of a closed tube? F0 equal to V over 4L. We now know F0. We know the value of V. Therefore, we can find the length of that tube. L equal to V over 4F0. And that will be, using the values of V and F0, we get the length of the tube as 0.324 meter. That has been a very good problem. I hope you understood the way we did this. Well, I'm now in a position to say that we have finished the Unit 1 of our course. That means it is time for you to get ready for Test 1. Now remember, I have given you a practice test. Now look at the practice test. and make sure you can do all the problems or all similar problems. Don't think that you're going to get the same problems for the test. Alright, now go and review all the homework problems and the practice test, and then you will be ready for the test. Alright, well, I wish you all the best, and I hope you will do well in your test. And I'll see you for Unit 2 later on.